Okay, question 3 of the 2012 exam. So, we want to find the original function, and we know it goes to the points 0 and 0. The gradient function, or the first derivative of y, is x squared minus 2x. So we need to integrate this equation to get us back to the original function y. So if I integrate this equation with respect to x, it will give me x to the power of 3 over 3 minus x to the power of 2 plus c. Now we know that the function goes through the point 0, 0. X is 0, y is 0. Y is 0 equals x to the power of 3. X is 0. Leaves us with c is equal to 0. So we know that our function is this. Next we'll plug in and find the point when x is equal to 6, what does y equal to? So the y coordinate is the point on the curve when x is equal to 6. So if I put y is equal to 6 in, then I've got 6 to the power of 3 over 3 minus 6 to the power of 2, which gives me 216 divided by 3 minus 36, which is 72 minus 36, which is 36. Y is 36 when x is equal to 6, so our just got up here for working, xy equals 6, 36. Right, that's our answer. Volume of a cube. Well, a cube has a width, a height, and a depth, all the same value. So if we call that value x, then x times x times x gives us that. Now the rate of change is simply v prime. So if we know v, our volume of a cube, derive it, gives us 3x to the power of 2. When the side length is 5, what is the rate of change? So what's the gradient of this equation when x is equal to 5? v prime of 5 equals 3 times 5 squared equals 75 centimeters per second, I guess. Centimeters per x. Yeah, confusing units, but 75 is your answer for that one. Right, question 3c. This is different from the one we saw earlier on, where we had to sketch the gradient function. Now we've got the gradient function, we have to try and figure out what we're going to have for the original function. So it's going backwards. So since we've got a quadratic, when we go backwards to the original function, the power is going to go up by 1. It's like we're integrating, we're going to go from a quadratic to a cubic. The gradient is equal to 0 at the turning point. So we know that this point here and this point here are going to be our turning points. We don't know where they are yet. In fact, we won't know where they are exactly. We're still sketching. But we can decide that the two turning points are going to be at A, and that other turning point will be at what looks like negative 2a. We know that when the original function is at a, its value is 0. So here at a, the value of the original function is 0. That's a turning point. You can also see that the gradient is increasing the whole way. The gradient is increasing, that means this is going to be a minimum point. So our other turning point has to be a maximum. So we're going to have a cubic that looks like this, goes through that point, that's a 0 gradient just there, comes back down, and we have another minimum point just here, and then it will go up again. So here we have a positive and increasing gradient, that's what you see in the function. Here we have a negative gradient, decreasing, decreasing to here, and then increasing a bit more until the gradient here is finally 0. And that's what we see from here to there. So that there is a sketch. Once again, has to go through that point. This point can be anywhere you choose. you want another color, another equally acceptable equation would have been that one there. Went through the main point, has the turning points lined up. That's all you need for a sketch. Right. Nearly at the end. Question 10. Now this is going to be a simultaneous equation. We have two things we don't know. A and B, we don't know them. We know that the gradient is 10 at the point x is negative 2. So if I take my original function and I plug in negative 2 plus a times negative 2 plus b, we know that the original function has a value of 33. If I take my derived equation, so I'm going to derive that equation really quick, equals 6x to the power of 2 plus a. I know that when x is negative 2, the gradient is 10, so I can put in 6 times negative 2 to the power of 2 plus a equals 10. From that I can solve this as 6 times 4, 24 plus a equals 10. A equals negative 14. Now I know a is negative 14, I can put it back into this equation here. That will give me 2 times negative 8 plus negative 14 times negative 2 plus b equals 33. So it's negative 16 plus 28 plus b equals 33. B equals 21. So now we've got our a value, we've got our b value. All we have to do is find what is our y coordinate when x is equal to 4. What is our f, what is our function when x is equal to 4? It equals 2 times 4 to the power of 3 minus 14, that's our a value, times 4, plus 21. And that equals 93. So that's our coordinates just there. X is 4, function is equal to 93. Alright. And our last question. Right, we've got a radius of 1 plus 2t. We know that the area of the circle is pi r squared, so the area of the semicircle is going to be a half pi r squared. We know that our radius is equal to 1 plus 2t, so I substitute that in. I'll expand it, I'll kind of simplify it. And lastly, I will take the derivative and find out what is the rate of change equation when it's equal to 60. Right, so if I derive this equation, I'm going to get 1 times, well that's just a constant, there's no t value there, so it's going to be 0. A half times 4t, so what's the derivative of 2 pi t? plus 2 pi t squared. So I have to derive that. That's what I'm going to derive. So that's going to be 2 pi plus 4 pi t equals 60. Right, let me just factor out 2 pi times 1 plus 2t equals 60. T is equal to a half. This is all rearranging in one step, so you can do it for yourself slower, step by step. Just check you get this. Minus 1, that in your calculator will give you T is equal to 4.27, that's seconds. You want to know the width of the pool. So after that many seconds, what is the radius of this? Because after 4.27 seconds, the radius of the semicircle will have gotten to exactly the edge of the pool. So we're going to have that. We want to know what is this distance here, what's that radius, also known as the width of the pool. R is equal to 1 plus 2t, 1 plus 2 times 4.27. That's going to give you 9.54. There might be some rounding error in that, but it's about that. And you wouldn't get marked down for rounding plus or minus 1. So the width of the pool is 9 meters. After that, you just have spare paper for writing.